Hello, everyone. We hope you enjoyed lunch. So funny enough, the music that you were just hearing was actually AI generated, which is quite fitting for this event. Welcome to our afternoon alumni keynote. My name is Linda Zhang, a co-president of WISTEM, and it's my honor to introduce our keynote speaker, AndrewJin. AndrewJin is the vice president of engineering at Cormor, a healthcare technology company developing AI solutions for providers and health systems. He leads engineering across the ambient AI and EHR business lines, focused on delivering the industry's most advanced LLM-powered productivity tools, including AI scribing, clinical co-pilots, and voice agents to clinicians everywhere. Andrew graduated from Harker in 2015, where he was active in the research community and won the Intel Science Talent Search. He went on to study computer science at Harvard and began his career at Meta, where he worked on search ranking algorithms. Motivated by a passion for impact and entrepreneurship, he later founded a healthcare startup focused on virtual care for musculoskeletal conditions. After 5 years of building and scaling, the company was acquired by Cormor in May last year. Today, Andrew continues to work on the intersection of engineering, product, and go-to-market with a mission to make cutting-edge AI tools accessible across the healthcare landscape. In this talk, Andrew will share his journey from science fairs at Harker to leading AI innovation at Cormor. Throughout the talk, please feel free to join the Slido and submit questions, which will be answered at the end. Let's give a warm welcome to Mr. AndrewJin.
Okay, thank you for that wonderful intro. Okay, hi everyone. So my name is AndrewJin, and as mentioned, I'm currently VP of Engineering at Cormor, and I was Harker class of 2015. It's an honor to be here, and thanks so much for inviting me to speak. So I was reflecting a little bit while preparing for this talk and realized that, wow, time really flies. I graduated from Harker 10 years ago and actually gave a presentation at the Research Symposium that year. So it's pretty surreal to be back here again 10 years later. I'll start with a quick outline of my talk. I thought about what I'd want to hear as a student and remember being in some of your shoes, wondering what life beyond Harker would be like. It definitely felt a bit scary peering into the unknown. Every person is different, but I wanted to share my journey as an example. It's okay not to know exactly what you want to do. It's okay to take a nonlinear path and make some unconventional decisions. I'm going to structure the next 30 minutes into 3 sections or so. First, my journey as a Harker student to give a glimpse of how it shaped me and ultimately brought me to where I am today. Second, my experience as a startup founder building a company in the healthcare technology space. Third, my work at Cormor applying LLMs and generative AI to build software for doctors and health systems. And finally, we'll wrap up with some reflections and Q&A. So at Harker, I developed an early passion for science research and was an active participant in the research ecosystem. I did my first simple research project in 8th grade, where I tested whether bacteria in household sinks developed resistance to common soap products. I participated in the local science fair and attended the research symposium, where I was inspired by the talks given by the upperclassmen. My interest grew from there, and so did the complexity of my projects. So I started attending research conferences nearby at Stanford to learn more, and still clearly remember a professor's talk about her research using computer vision techniques to predict cancer progression. That's how I became fascinated by machine learning, particularly when applied to biology and medicine. So that's me right there while I was a student at Harker. For my junior year project, I leveraged data on gene expression and cancer treatments to discover synergistic drug combinations that work better together than alone. And for my senior year project, I trained machine learning models to discover genes and mutations responsible for our evolution as human beings, with implications for uncovering new drug discovery targets. And that's me actually giving my symposium talk here 10 years ago on April 11th, 2015. So research at the intersection of AI and healthcare has been a thread I've continued to pull on throughout my career. But how do I end up in the world of startups and entrepreneurship? While refreshing my memory for this talk, I found an article online about my junior year research project. In it, I talked about how I wanted to become a professor or start a company in the tech or healthcare industries. Given my passion for science research, I thought I'd be more likely to go down the academia path. So how did I decide on startups? While I loved research and the thrill of making new discoveries, translation to real-world impact is often challenging, and the timelines are extremely long. While I loved, so my summer after graduating from Harker, I interned at Facebook in their machine learning group working on search ranking algorithms. It was an amazing feeling being able to write code for a few weeks and ship something that was immediately used by millions or even billions of people. But I quickly realized that I didn't want to train cutting-edge models just to get people to click on more things on Facebook or spend more time on Facebook. So I wanted my work to create significant positive impact in the world, which is sort of what I set out to do on the research path to begin with. So after graduating from college, I decided to embark on what at the time was a more unconventional career decision. Instead of taking a stable, prestigious job in tech, consulting, finance, or medicine, I took a leap of faith and started my own company, Dorsal Health. We focused on solving a problem that was very close to my heart. The US healthcare system, as you probably know, is pretty broken and fragmented, suffering from high costs, poor outcomes, and limited access to specialists, especially compared to other countries and other parts of the world. We tackled this problem by building a comprehensive virtual care platform to connect patients with specialty providers. We were fortunate to launch right before COVID, and we benefited from a couple key societal shifts. First, massive consumer adoption and acceptance of telemedicine pretty much overnight. And second, regulatory changes that made it easier for doctors to get licensed and treat patients in different states. We quickly scaled to serve thousands of patients per month by hiring and training over 50 providers and getting them licensed to treat patients across 30 different states. We also built innovative software to power our own vertically integrated care delivery platform, spanning areas like patient intake, virtual doctor visits, and medication delivery. For example, we built our own AI-powered electronic health record, or EHR system, as well as productivity tools to increase the number of patients that each provider could see in an hour by 5x without compromising on care quality. In the physical world, it might take a year for a new provider to start a practice to serve just a single city, and it might take 5-10 years to expand across a larger metropolitan area or state. But in the virtual realm with software and technology, we're able to treat any person in the country and expand it to 30 states in the span of just a few months. So after building and scaling the business for 5 years, we got acquired by Khmer about a year ago in May of 2024. And that leads me to the main focus of this presentation, which is also the part that's most topical to the theme of this year's symposium. I'll talk about the work we do at Khmer involving generative AI and LLM applications in healthcare. So the issue we're addressing is pretty clear. The healthcare industry is at a breaking point, burdened by administrative complexity, skyrocketing costs, and clinician burnout. We believe technology should alleviate these pressures, not add to them. Over $250 billion is spent each year on administrative overhead alone in healthcare. There's this massively complex web of back office workflows spanning old school phone calls, faxing, paperwork, documentation, and more. It's pretty much the perfect problem to tackle with large language models. At Khmer, we're building a suite of AI tools to benefit providers, administrators, and patients alike. These products are meant to serve all segments of the market, all the way down to your solo practitioner running their own small business in rural Idaho, and all the way up to the largest hospital systems in the country. The company is currently valued at $6 billion and has raised hundreds of millions of dollars of funding from top VCs like General Catalyst, Sequoia, and Green Oaks. We have over 1,000 employees and are operating at pretty immense scale with 500,000 providers using our software and over 100 million patient interactions powered in 2024. So now let's take a step back for a moment and talk about the bigger picture. One of the long-standing grand challenges in AI has been developing systems that can reason over complex medical knowledge and answer clinical questions at the level of a human physician. This graph comes from a paper by Google Research on MedPalm 2, their large language model fine-tuned for medical question answering. The benchmark they used is called MedQA, which is based on the US medical licensing exam, the same type of questions that future doctors must pass to become licensed. To give you a sense of the difficulty, random guessing gets you about 25% on this multiple choice exam. A passing score is around 60%, and expert level performance, the kind you'd expect from a board certified physician, is in the 85 to 90% range. As you can see, LLMs like MedPalm 2 are rapidly approaching expert level accuracy. It's a pretty powerful example of how far the field has come in just 3 to 4 years and how close we are to building AI systems that can truly assist with complex medical reasoning. In fact, I'd argue that we're probably already there. In light of this, though, there are obviously major ethical ramifications to consider. The risk of inaccurate diagnoses or hallucinations. If patients are harmed, who is responsible? The developers, the deployers, or the model itself? LLMs lack true clinical understanding and can't pick up on nonverbal cues. They're trained on biased data and can amplify existing healthcare disparities. We need to think about the data privacy and security concerns. The list goes on and on and on. I want to turn our attention to the optimistic view and talk about responsible use cases. The goal is to use AI to augment and enhance rather than replace the expertise of human physicians. I'll highlight 2 clear use cases. First, as a clinical decision support tool. LLM copilots can assist physicians by surfacing relevant information, generating differential diagnoses, or recommending evidence-based treatments, always under the supervision of licensed professionals who make the final judgment. Second, reducing documentation burden. AI medical scribes can listen to patient-provider conversations and generate structured visit notes, freeing physicians from hours of administrative work and allowing them to focus more on patient care. These applications improve efficiency and reduce burnout, all while keeping critical decision-making in the hands of trained physicians. So for this talk, I want to take a little bit of a different spin and really focus on how we're applying some of these cutting-edge research models and techniques to real-world applications and show some of the demos of the work that we're doing at Khmer and the products that we're putting into the hands of every clinician in the country and even the world. So as mentioned, this is the demo of one of our flagship products, our AI Medical Scribe. So I'll start by reading a sample dictation, a very toy example. The patient is a 45-year-old male presenting with a 3-day history of cough, fever, and fatigue. He denies shortness of breath or chest pain. On examination, vitals are BP 120/80, HR 78, temp 100.4 degrees Fahrenheit. Lungs are clear with no wheezing or crackles. Based on the symptoms and examination, the assessment is an acute viral upper respiratory infection. The plan includes rest, fluids, and Tylenol for fever. The patient is advised to follow up in 3 days if symptoms persist. And then we'll end that recording. And you'll see this process for maybe 5-10 seconds or so. And it gives us a perfect transcription of that dictation or patient encounter. We see a fully structured clinical SOAP note. It generates a patient email with a summary of the visit. We can even help assist with ICD, CPD codes for billing purposes. And there are a few other cool things we're able to do. We can make the note more detailed. We can make the note more concise, depending on the specialty, the use case, the provider preferences. We can dictate real time using speech-to-text models, and providers can speak medical terminology instead of typing it. We can also learn the provider's preferences, and they can show the model examples and help the model get smarter and smarter over time for what the provider wants it to do. And we also have a clinical co-pilot that's embedded right in the scribe view, where the provider can ask questions about the encounter, can use it to modify the documentation, can use it to handle other administrative tasks like writing prior authorization letters based on this particular visit or this particular note. So yeah, really cool what we're able to do, which at the end of the day, it's just a pretty simple product built on top of a couple generative AI models. You have a speech-to-text model from the likes of OpenAI or Google, it's Gemini, and then you use an LLM from something like OpenAI or Anthropic. So what's the impact of a product like this? The stats are pretty staggering. Physicians spend nearly half their day documenting, with an extra hour and a half on average at home finishing their notes outside of work. This simply is not sustainable, and Comere's Ambient AI Scribe product is here to change that. Now it takes under a minute to complete and close a note for an encounter. It might take 5 seconds to generate, but the clinician will still go in and do the final review. And overall, we allow clinicians to save an average of 2 hours per day for their clinical documentation. And what does this actually look like in terms of product growth? So in just a matter of months after launching, our AI Medical Scribe product saw explosive adoption across clinics and health systems, driven by provider demand for a product that solves one of their biggest pain points and frustrations. We're now scribing millions of appointments annually, with usage approximately doubling every month or so. We also built an AI-powered medical receptionist that can answer inbound calls, schedule appointments, collect intake information, and route messages automatically, 24/7 with a natural human-like voice. Medical practices are routinely understaffed, and all of us have probably experienced how frustrating it can be to get stuck on hold for an hour when trying to schedule an appointment. So this is a pretty simple text demo of how we can just prompt an LLM model to serve as this AI receptionist use case. It might be hard to see, but it gives you a general sense of what's happening, and then I'll follow up right after with an actual voice demonstration itself. It goes through a conversational flow. It has access to different tools and function calls to look up appointment availability, to collect patient information, and ultimately book in a visit. And it's quite impressive how quickly the research behind these text-to-speech models have been developing. Just a half year ago or so, we were probably still stuck in the uncanny valley where the voices sounded too robotic and latency was too high to be used for real-time conversation applications. And now this is an example of where we currently are.
Thank you for calling Ready Care Physical Therapy. This is Sarah speaking. How can I help you today?
What can you help me with?
I can help you schedule, reschedule, or cancel appointments, answer any questions you might have about our services, and assist with insurance inquiries. What do you need help with today?
Could I schedule an appointment, please?
Absolutely. May I have your full name, please?
John Smith.
Thanks, John. And could you please provide your date of birth?
May 20th, 1990.
Got it, John. What brings you in for physical therapy today?
I sprained my knee playing pickleball.
I'm sorry to hear about your knee, John. Let's get you taken care of. Do you have a preference for which therapist you'd like to see?
No, no preference.
That's fine. We can select a therapist for you. Do you have insurance you'll be using for this visit? If so, could you provide the plan name and policy number?
I don't have that with me at the moment.
That's totally okay, John. We can come back to that later if needed. Now, let me check the availability for your appointment. Just a moment, please. I found some available times for you. You can come in on Monday, April 14th at 10:30 a.m., or you could choose Monday, April 14th at 2:15 p.m., or even Monday, April 14th at 4 p.m. Which one works best for you?
Do you have any availability for the following week?
Sure. The following week, we have an appointment available on Tuesday, April 15th at 9:15 a.m.
Yeah, I think I can do that.
Great choice. So you'd like to schedule your appointment for Tuesday, April 15th at 9:15 a.m. Just to confirm, could you please provide any insurance information, like the plan name and policy number, or would you prefer to handle that later?
We can handle that later.
That's perfectly fine, John. So, to recap, you're all set for your appointment on Tuesday, April 15th at 9:15 a.m. Please remember to bring your...
Yeah, so that's just kind of a toy example, but it's pretty remarkable how far we've come compared to, a couple years ago. And these models are just so flexible and robust compared to some of the more, traditional IVR approaches of the past. So what we do, though, isn't just limited to product engineering and purely applied AI. We also have more open-ended research challenges where novel thinking and problem-solving skills become very important. And I get to scratch my research itch and exercise that muscle a little bit as well. But still, with quick translation to real-world impact and usage by customers. So in the spirit of the Research and Symposium, would love to share a few of these challenges. For example, we need to figure out how to maximize transcription accuracy and documentation quality with a sort of constellation of models approach. We're not just using one model, we're not using just one LLM. We found that, just like real people, these models have different personalities, they have different strengths and skills and weaknesses. So Anthropic's Claude model, for example, very good at writing, very good at not making up information and hallucinating, very good at kind of writing medical notes in a structured way. So we might use that for the initial note generation. OpenAI's GPT-4o might be better at following instructions for a doctor's custom formatting or custom preferences. We might use multiple different Claude models running in parallel to review each other's work to avoid any model going down a rabbit hole, right? And that's important because medical use cases have to be incredibly accurate and resilient to hallucination. We might, use GPT-4o Mini to structure a note into sections to then write it back into a provider's EHR system. So that's one example of something that we might work on. Another example is how we might customize the experience to each specialty or each clinician's individual unique preferences with fine-tuning or multi-shot prompting. We also need to use LLMs to create an automated performance evaluation framework to help choose the best model and facilitate prompt engineering. The industry is moving extremely quickly. There are endless options and what seems like new state-of-the-art frontier models getting released every single week. Gemini 2.5, Claude 3.7, Grok, GPT 4.5, DeepSeek, you name it. So how do we quickly make decisions and iterate on prompts with confidence while ensuring that we're not regressing across thousands of providers and tens of thousands of daily scribes, all with very unique and differentiated preferences. And finally, we'll also use more traditional deep learning, recurrent and convolutional neural network techniques to pre-process audio for transcription and voice agent applications, detecting when somebody is speaking, removing noise to make turn detection or make transcription more accurate, figuring out when someone's done with their part of the conversation so that the agent can start speaking, and that's how we can minimize latency and make it as real time as possible. So just a few examples of the research that we are also pushing the boundaries of on, and how we kind of will mix that in with peer applied product work. Finally, we build a lot of AI tools at Khmer, but I want to end this section by also talking a bit about how we leverage AI tools ourselves to supercharge our impact and productivity. So we'll use tools like Cursor, Bolt, Vercel v0 to generate boilerplate code. So the code for this front-end application for our voice agents was over 95% written by AI. And something that previously took weeks and multiple developers can now be done by a single person in just days. And this completely changes the physics of how quickly we can build new products, get them into the hands of customers, and continuously iterate. Our developers can now stay focused on what really matters, implementing high-level differentiated application logic, and figuring out how to build features that solve real customer problems before they'd often be spinning their wheels and getting stuck in the weeds with low-level repetitive front-end tasks like writing HTML and CSS and figuring out how to bash bugs. And then the other use case I'll share is deep research and data analysis. So we wanted to actually analyze our data set of how providers will use our clinical copilot tool. What messages do they send? How can we further build on and extend the product? And there are probably tens, if not hundreds of thousands of messages coming through. Impossible for us to read through each one. So we took the 10,000 most recent messages and actually put it through a tool called Manus, which is built on top of Anthropic's Claude models with a lot of different tool use calls. And we asked Manus to generate a report and turn it into an interactive website. These sorts of knowledge and insights that used to take at least a couple of days to mine and uncover can now be surfaced in mere minutes. And that helps us kind of figure out how we supercharge and extend our product as quickly as possible. So what did this analysis find? And how do clinicians actually use our Copilot product? So we see that top use case is for treatment planning and management. So sort of that clinical decision-making use case, about 19% of questions. About 11%, so the number 2 use case was documentation assistance, ICD, CPT coding and billing support, prior authorization letter drafting. 3rd, diagnostic assistance. 4th, medication management. 5th, lab and test interpretation, and things like that. Professional communication. So pretty cool that we can just run this through AI and get these insights in the span of minutes instead of days where we'd have to kind of pull a data scientist or pull an engineer to surface these insights. And now we're able to take this work, take these insights and figure out what are the next features we're going to build into our product. What are the next use cases that we need to talk to the clinicians to better support and iterate on. All right, so that ends that part of the talk for me. Hope it was productive and interesting for all of you in the audience. Finally, as a former Harker student, wanted to kind of share some reflections and insights and potential advice. A few different points that came to mind as I was reflecting on what I might want to hear as a student, what I wish I knew 10 years ago. So I think my time at Harker, it was definitely some of my most productive and formative years. So I would say definitely take advantage of everything that Harker has to offer, even if it might not be apparent how it might benefit you down the road. Explore broadly, find your passion, learn from and get inspired by your peers and teachers. But it's also important to be pretty well-rounded. So it may seem like that all I did was research and machine learning and programming, but I also did debate, had leadership positions in clubs, really enjoyed our English classes, and that definitely made me into the person I am today. Being able to think independently, being able to research, being able to communicate effectively and clearly. And also, met a lot of amazing peers who I still learn from to this day, and that's definitely, something that I think can go underappreciated. Just everybody at Harker has insane high caliber and talent level, and you'll continue learning from them down the road. You know, fellow founders that I still lean on and rely on for advice, people that I work with at work. So yeah, definitely something to keep in mind. Second, I would say is embrace AI, but you still need to establish strong foundations, those critical thinking skills, how to ask the right questions, being able to clearly express your ideas. I would say, you know, with the right foundations, AI is definitely a superpower. You can be, you know, 5 to 10 times more productive and effective in ways that I shared of how we might use AI tools at work. But without them, and I see, you know, a lot of people too, in the work realm where, you know, they never set those right foundations. They kind of grew up in an era where AI tools were so easy. You can like ask AI to solve your CSP sets that, you know, I previously would struggle through and pull all-nighters for in college to figure out, right? So I've found that, you know, without those strong foundations, you're probably worse off compared to not using AI at all. But I would say, you know, the physics of building products and conducting research have completely changed. So much more is possible and within reach now, even for, you know, students like yourself. You have an expert constantly at your side that you can learn from. It's easier than ever to build. What's important now are probably things like customer empathy, domain expertise, and understanding of pain points, product sense, taste, things of that nature. And then the final point I'll share is, I think most importantly, use, you know, your time here, use your time in college, use your time after that to really just, you know, figure out what you're passionate about. It's much easier to get really good at that thing and enjoy the journey, enjoy the job, enjoy, you know, the whole process. And I would say it's totally okay to take a non-linear and less conventional path, you know. Through high school, I thought I wanted to go down the academic path and go deep into research and become a professor, but it's taken me kind of down a different journey where now I'm deeply embedded in the world of startups, but still, you know, exercising that muscle, still using a lot of those skills that I learned and developed as a student, as a researcher to figure out, you know, how to apply cutting edge advances to deliver real world impact and value and get these products into the hands of thousands, tens of thousands, millions of providers and patients. So yeah, and then finally, you know, want to wrap up with an obligatory recruiting pitch. So we're definitely hiring aggressively at Camille. So friends, siblings, family members who might be excited about the prospect of tackling technical challenges that are very interesting and impactful in the healthcare industry, we'd love to talk to them. And high school students too, you know, with strong programming or business experience, we're always open to internship projects, you know, working with students. So feel free to reach out to either me or we also have Nikki here in the audience. She's Harker class of 2020, and she's our chief of staff. So super awesome person to reach out to and connect with as well. And then my boss, our CTO at Camille, he also is a Harker alum. So pretty cool connections to the school all around. So yeah, amazing network there. Yep, and then finally, you know, any doctors in the audience who might want to talk about their pain points and how software and AI can make an impact on their day-to-day lives, would love to chat to learn more. And our mission at the core is letting doctors focus on what matters most, which is delivering high-quality patient care. And then, you know, Nikki has planned an awesome panel of events. So that's also something that we want to open up to the Harker community. We're hosting a speaker series at our office in Mountain View. So feel free to come through. A lot of really awesome investors, really awesome speakers. We have Alfred Lin coming from Sequoia, investor in DoorDash, Airbnb, amazing generational companies. We have Glenn Tolman, you know, who built Livongo to the largest exit in digital health history. So awesome speaker panel, and you can take a picture of this, scan the QR code, and sign up. And with that, I will finish the presentation and open up for questions.
How did you become such a successful researcher? What was your inner motivation at Harker?
Let's see, that was definitely a long time ago, but really good question. I think for me, the motivation was like, I just got really interested in research. And I think like the education here definitely helped a lot with that. So, definitely want to shout out to some of the teachers, including Dr. Nelson here. I think I took like 4 or 5 of his classes, neural networks, a lot of advanced topic CS classes, physics. So I think, being able to get exposure early on to these spaces helped me figure out like, wow, this is something I was super, super interested in. And that was definitely like my cup of tea. I tried things like Math Olympiad, Science Olympiad, and I think for me, research is just what spoke to me, and I was very curious and very passionate about kind of that feeling of using everything I learned as a student here, using kind of the superpower that I felt, programming and computer science gave me to just discover new things. So I think those were my inner motivations. I would say like how I became good, definitely get like the reps in early on, and I think the difference between my 8th grade science project and my 9th grade science project and my junior year science project and senior year science project was kind of night and day. But each time, going through, learning from the upperclassmen, coming to these sorts of events, seeing, what that next level could look like was super powerful. And then obviously being able to work with great mentors, whether that was like mentors like Mr. Spenner or Dr. Nelson at Harker, or the professors that I was able to work with. And I would say like, I think like that's something we're really good at here is showing students how to kind of go out there and be proactive, even like early on. So early on, like in 9th grade, I was reaching out to professors. I was finding, really awesome people to work with. I was going to nearby presentations and talks at Stanford. So I think being able to, just work with amazing, amazing people is probably, most important. And that is also something that like stays true throughout life. It's like, how do you surround yourself with the best people, the best talent that you can learn from?
And how did you find a meaningful research topic?
So I think I covered this a little bit, but really quickly, it was just like, put yourself out there, kind of create opportunities for serendipity, create, opportunities for spontaneity. So I think for me, I would sit in a room and try to think and think and think and read a bunch of papers and see what inspired me. But it was really easy to kind of just bash my head against a wall and run into a block. But I think, I went to that Stanford Symposium and immediately, something clicked and sparked my interest, where I listened to a talk from Daphne Kohler about applying computer vision to predict breast cancer prognosis and severity. And that just immediately really interested me. And I can't really explain why, but that just inspired me to kind of go deeper and deeper and deeper, read more papers, go through their citations, and I would say just like kind of follow a similar process like that, create opportunities for yourself to get excited, create opportunities for you to kind of go really, really deep, and then, something will probably come out of it.
How do you ensure your tools remain effective and accessible in low resource settings, like hospitals with limited bandwidth, weak Wi-Fi, or minimal computing power?
Yeah, that's also a really good question, and that's where kind of the pure like engineering chops come in. That is definitely something you kind of have to think about from day one, and it sets great products apart from mediocre ones. And actually kind of funny that this question is asked, because yesterday we had a speaker at our office, Neeraj Arora. He was the chief business officer of WhatsApp, and that was kind of what made WhatsApp great. All these 50 bajillion chat applications were all focusing on people in the US who had really good iPhones, right? And they left all the people internationally in places like India, Africa, Latin America, on 2G, 3G internet at the time. Like, they weren't thinking about that demographic. So WhatsApp came in, really, really strong engineers. They just focused on getting that super performant and super right, where they did things like, instead of loading all the messages when you log in and connect to the server, all the messages were stored locally on your device, so they would load right away, right? And we remember like back in the day, like everything feels a lot more robust now, but I still remember back in the day where my apps were crashing left, right, and center, but WhatsApp would just reliably be fast and performant. So I think it's like a very similar mentality for us in this world as well, to build the most useful products, because we do work with a lot of rural clinics. We do work with a lot of like hospitals where you might not have consistent Wi-Fi, right, across each floor. And like the most frustrating thing we hear from customers is, I recorded a very, very important patient visit for an hour and it got lost because our connection was lost, right? Or my app crashed. And that's enough to get them to go to a competitor. And there are a lot of competitors out there right now. So that's where like we have to think about optimizing every single second of loading speed. We have to optimize every single piece of friction. We have to make these things work in an offline capacity. So like, for example, every 30 seconds, we are saving the audio locally. We are uploading the audio to the cloud, right? So at any point in time, if your app crashes or if your Wi-Fi fails, you still have a local copy on your phone or some section already saved to the cloud that you could re-upload or resume later, right? So things like that, that's just one example, but there are probably like 5, 6, 7, 8 other things that we do of that capacity.
Did you use real-time or a regular query transcription, if at all? And if not, how did you implement audio-to-audio responses? If so, how did you implement text-to-speech without multiple unnecessary queries?
That's also a really good question. I'm not sure if it's applying to the Scribe product or the voice agent product or both, but I think specifically answering the context of the Scribe product, you can use real-time transcription models, smaller versions of Whisper. DeepGram is a really good real-time model, but the accuracy is going to be a lot worse versus you have larger, more sophisticated models from like Gemini, which might have higher latency. And I think for us, it's very important to always think through and evaluate those trade-offs. So in this case, as long as you're able to transcribe something in like under a couple minutes, the provider's usually pretty okay with that because they might, stagger their documentation. They might finish the next visit first before they come back and transfer the notes into their EHR. So in light of that, for us, we realized it was a lot more important for a provider to have a highly, highly accurate transcription where they could trust it and not have to go in and, edit the errors or review the whole transcription to identify errors. So we're okay, not transcribing in real time. But we can still optimize that in certain ways. We can send the audio chunks in real time every 5-10 minutes during an hour-long recording. And that way, you're transcribing in real time as the packets come through. You can do some work around figuring out if any packets get dropped, then I can kind of fall back and go back to using the entire chunk at once. But that lets us kind of not be bottlenecked and really, we're kind of just limiting the latency to how long it takes to transcribe 5 minutes of audio instead of an hour's worth of audio. So I hope that answers the question.
Last question, is Commure planning on developing internationally? If so, what's the plan?
Yeah, I would say the US healthcare system is uniquely broken. So there's the most opportunity, the most commercial value to be had in the US healthcare system. But the beauty of these products is we can just quickly put it out there to the whole world the same way products like Cursor or ChatGPT grew. We can benefit doctors in all countries, right? Because medical notes are medical notes. And these models can sort of effortlessly out of the box translate across 50, 60 different languages. So we have been making an international push. Big kind of areas of focus have been Australia, Canada, New Zealand, the UK, the primarily English-speaking countries. So yeah, definitely a big area of interest for us.
So that was our last question. So let's give Andrew a big round of applause.